Hello everyone, a very warm welcome to our channel Smiley Kids. Let's move on to the next part of functions today. The topics we're going to cover today are the difference of two sets, symmetric difference of two sets, and De Morgan laws. So let's begin. Difference of two sets. Yet again, let's focus on the Venn diagram that is there over here. Now, before I even talk about this diagram over the screen, I want to take several examples to understand difference of two sets. Okay, let's suppose say 1, 2, 3, 4 is one set where I'm going to subtract it with 3, 4. Now tell me what would be the result? Well, from this set you're subtracting 3 and 4. That means 3 and 4 elements are gone. Now you're going to have 1 and 2. That will be your answer. Now this is very simple, right? Now what if I go on with the next example saying I have 1, 2, 3, 4 and I subtract 3, 4, 5. Now what does this mean? 3, 4, 5 here, there is no element 5 here. But that doesn't mean that you're simply going to write 5 in the answer. No, you're subtracting 5. Yet it's there or not, that's none of our concern. But you're not going to have 5 in your answer, right? So again 3 and 4 is gone. 1 and 2 will be remaining. Alright, though there exists no 5 in this. Fine. You're just removing these elements. If they are not present, then you need not worry. They're already removed. Alright. Now let's move on to the next one. I say 1, 2, 3, 4 minus 5, 6, 7. Now tell me what will be your answer? Well, it's not 5 or it's not this 5 or it's not 0. No, it is 1, 2, 3, 4. Why did I write 1, 2, 3, 4 over here? That is because everyone, from this you're removing 5, 6 and 7 elements, but they are already not present in this. So you need not worry. It's simply the same set that mirrors your answer. Now I hope you understood the difference of two sets. Now let's quickly move on to the Venn diagram. Here we have set A and set B again. Here I am going to subtract A and B. Set A minus set B. Now what does this mean? This is set A. I am going to remove set B from A. What does that mean? That means this part is getting eliminated. This part comes under set B as well. That is the common part for both A and B, isn't it? So you're going to remove this part. Try to visualize it. It's not something that I'm going to tell you and then you're going to understand it. No, you're supposed to visualize it, right? A minus B. That means this is set A and whatever the part of B is there, that is getting removed or eliminated, right? Now what is the leftover part in your set A? This part. And that is the difference of these two sets, isn't it? Now this is the Venn diagram for the difference of two sets. Alright, let us take on a quick example, making our concepts clear. Here I have 1, 2, 3, 4, 5, 6, 7. Now what is A minus B? This is A, this is B. What is A minus B, everyone? This part, that is 1 and 2 will be the answer for A minus B. Let's understand this in this manner. What is A equal to in the given Venn diagram? 1, 2, 3, 4. And what is B equal to? B is equal to 3, 4, 5, 6, 7. Now, A minus B, that means 1, 2, 3, 4 minus 3, 4, 5, 6, 7. What does this mean? Is 3 present? Yes. I'm going to eliminate it. 4, eliminate. Then 5, 6, 7 are already not present. So what is our new set over here? 1, 2, and that is it. This is called the difference of two sets. Let's move ahead and understand the symmetric difference. Now here we have A delta B equals, here A delta B is nothing but the symmetric difference, right? So this is gonna be A minus B union B minus A. Now what is this Latin on screen? Let me make you clear by Venn diagram again. Alright, A minus B. Let's say this is set A and this is set B. Let's first understand the formula and then solve an example to understand it better. Now from A you're subtracting B. This is my A and here there is some B over here. I'm going to eliminate that B. Alright, elimination with red. Now what is the leftover part that is there? A minus B will give you this part. Right, fine. Now let's move on and find out B minus A. This is B and you're subtracting A from it. Again this part is getting eliminated. It does not have any respect here. Right, that means what is left over here? This part. And the union of A minus B and B minus A will simply give you the symmetric difference of two sets. That means this part and this part is nothing but symmetric difference of two sets. Alright. Now let's quickly put on an example to understand it better. And this is not something that you get it in one go, right? You'll still have to revise all of these concepts. Now example, I have a Venn diagram, let's say. Two sets A, B. I have 1, 2, 3, 4, 5, 6, 7, 8. Now, I ask you find out the symmetric difference of two sets. Let's not go with this part, like simply identifying the part and then, answering the question. But let's just go with the formula that is there. A minus B, that means here, this is A. I'm subtracting B from it. That is, this part is getting eliminated. What is the leftover part that is there? 1 and 2. So I'll put on 1 and 2 union. You'll still have to need this union, right? And then I have B minus A. This is my B. I'm subtracting A from it. This is getting eliminated. What is the leftover part? 7, 8. Isn't it? Alright. Now that is the case. Now you're going to take the union of this. What is that going to be equal to, everybody? This is simply going to be 1, 2, 7, 8. And this is the symmetric difference of two sets. Now the questions are not always direct, giving you the Venn diagram and asking you, right? They can also be numerical. Let's say I have A and B in these two manner. Alright. Now A minus B will be what? These two elements get cancelled. You'll have 1. Union. Now what is B minus A? What are we talking? 2, 3 minus 1, 2, 3. That means here you have 1. But here you do not have 1. So that means simply 1 is already removed previously, right? And here we have 2. Gets eliminated. 3 gets eliminated. Right? What is there? Nothing is there, isn't it? So you're simply going to have 1 in your symmetric difference of two sets. Let's visualize this. If you're still having concern related to Venn diagrams, here we have set A, set B. I have 1, 2, wait, 2 and 3 are common, right? So 1, 2, 3, and then we have 2, 3 over here. That's comprising B already, right? Now, A minus B gives me this part, right? So here we have 1. Let's put on 1. And then B minus A gives me this part which is already empty. And that is the symmetric difference of these two sets. Let's move ahead and understand the De Morgan laws. Let me present you the De Morgan law 1, which says A union B whole complement equals A complement intersection B complement. Well, it's Latin, but let me make you clear over here. This is my Venn diagram, A, B. Now, what does A union B mean? It's already something that we have already read, right? So, this part is A union B, right? Which is going to include elements 1, 2, 3, 4, 5. Now, what is the complement of this? The complement of this will be all the leftover region that is there, which will include 6, 7. Now, this is my LHS part, which I am simply going to note down over here. 6, 7. This is my LHS. And I'll verify the RHS. Let's visualize them again. Alright. Now, here A complement, intersection, B complement. What does that mean? Two sets A, B. A complement means excluding this region, every other region that is there. Now tell me in the given example, what is that excluded region you're going to remove it? That is full A is something that you're going to remove. You'll have 4, 5, 6, 7 intersection. What is B complement, everyone? B complement, you're going to remove this part. You'll have 1, 2, 6, 7. Now we are going to find out the intersection of these two sets. How is that possible, everyone? Here, have a look at this. Let me represent these two sets in this manner. 4, 5, 6, 7 is common. So 6 and 7. Well, let me put on a bigger Venn diagram. Let us understand intersection well, because that plays a key role in our problem. 4, 5, 6, 7. And here you have 1, 2. Alright, this is set A and this is set B. Now tell me, what is the intersection of these two sets? Well, it is definitely 6, 7, isn't it? The common elements that are there, they form the intersection. Here also, if you have a look, excluding this Venn diagram, alright, have a look at this. The common elements will become the intersection. 1 and 2, they are not present. I am simply going to cut them off. 6, 7. Are 6, 7 present? Alright. Then they will be my intersection. 6, 7. Now this will be your RHS. Now have a look at LHS over here and RHS over here. That is my De Morgan law 1, which says A union B whole complement equals A complement intersection B complement. Now presenting you the De Morgan law 2, which says A intersection B whole complement equals A complement union B complement. Alright. Here there's simply the change in union and intersection that we have seen. Now let's focus on LHS first. A intersection B. I have AB. Yet again I'll take an example. 1, 2, 3, 4, 5, 6, 7. Now A intersection B means the common element that is there, that is 3. Now complement of 3. What is complement of 3, everyone? Every other region except 3. Now what does that mean? 1, 2, 6, 4, 5, 7. Alright. Every other region except 3. Now this is my LHS. I'll simply put this aside for a while. Let me try to focus on RHS now. RHS says A complement. Now what is A complement, everyone? Every other region except A, isn't it? Which is going to include 4, 5, 6, 7. Union, what is B complement? My B complement is going to have 1, 2, 6, 7. Are we right? Yes. So here we are going to take out the union. Alright. Now some of you might already arrive to this step saying that 1, 2, 4, 5, 6, 7, 6, 7. Now this is completely wrong. Elements in the sets are not repeated. right? You're simply going to have one time 6, 7, isn't it? Now pay attention to LHS and RHS. 1, 2, 1, 2. 6, 7, 6, 7, 4, 5, 4, 5. Done. And that's why here we have LHS equals RHS, which means we have to De Morgan law too. One thing that I want to keep here in mind is while you're taking a complement of any set, make sure here we have taken A complement. That means you're going to exclude A as a whole. You're not going to focus on the common elements as well. You're not going to consider 3 at all. That is something that you have to remember. While you're taking complement, you're going to eliminate the entire A or the entire B, irrespective of there's a common element or not. Alright. That dives us to the end of this video. Make sure you hit the like button, share and subscribe. Thank you.